Good afternoon, everybody. Today, we intend to discuss on optimization of the ladle refractory life and cost pattern. Amit Mukhopadhyay. When you talk about ladle refractory, then it doesn't make any big impact in the integrated steel plants, MS and SS mills. The reason is the unawareness, availability, no thoughtful interaction with the refractory suppliers, and above all, the analysis of the ambience to choose the right material for the right ambience. Let's imagine it's a small MS making setup and the casting ladle can be of alumina brick, quartzite or used ramming masses, magnesia carbon bricks in the shop having LRF, etc. But think about this, why these wide variations? Refractory selection. Refractory selection for any section is an important act to perform since every shop is unique. Usually metal temperature, slag kinetics, composition, temperature, viscosity, thermal shock possibilities, tapping techniques, time, discipline, number of ladles are available in the shop, etc. If it is just MS and process flowchart is induction furnace and CCM, then possibly quartzite ramming mass or 70% alumina would be the choice or even used ramming mass. So every melting shop is unique and the aforesaid areas should be explored along with the potential refractory suppliers. Speaking of the melting shop, people can understand the steel making or the skill or workmanship, not the refractory analytically. Bigger shops can employ refractory engineers, but again, the fine line which makes the bridge in between of the refractory know-how versus the cares towards refractory management can't. In such cases, the quality of the refractory, specific properties, shop characteristics, equipment, zone strengthening, either by qualitative enhancement or by the size or shape enhancement. These are not the cup of tea for the shop person. They requires the knowledge of the refractory manager who understands the zoning or qualitative aspects, etc. Design. When you go for the completely new shop, then probably a discussion with the supplier can make the refractory proposal as go for it without any amendment. But when you go for the older shop, when we should continually evaluate the performance and the conditions favorable towards the refractories, a continuous audit can improve the performance, even not in numbers, but in refractory consumption in pattern and cost pattern. Imagine the transfer ladle in an SS producing shop lined with 70% alumina bricks, and the light comes 50 to 60 hits depending upon the holding time and the impact of metal stream on the bottom shapes. The hypothetical cost pattern is say X, the continuous auditing specifically whether in the following direction. Change the bottom bricks quality to 80% alumina. Change the bottom brick size and increase the heights up to the allowed limit. Change the bottom bricks to AMC. Change the bottom bricks and the knuckle areas of the ladle to improve quality. Change the entire ladle refractory quality. Start deslagging in the induction furnace. After tapping in the ladle, let's start deslagging from the ladle. Any other options which can improve the lives. But at the end of the day, our objective is the refractory cost pattern must be optimized in the business perspective. So which decision to be taken to go ahead is a critical thing to consider, and it requires the thoughtful guidance of the plant officials who understands the critical behaviors of steel, slag, temperature, thermal discipline, etc. Construction. The second line is lining construction, which requires patience and guidelines. The mason team must be guided to keep minimum joints in the lining wall. Key bricks must be well prepared. Backfill must be well maintained with correct material to take care of the expansion contraction of the refractory shapes. Top brim to be maintained with castable cement patching for the lining shapes compactness. Circulation. Thermal discipline of any refractory lined ladle should bear a very specific thermal discipline, whether it is quartzite, high alumina, dolomite, AMC, magnesia carbon. The thermal discipline will maintain its behavior of thermal shock resistivity and other thermal behavior along with justified soaking. Ladle vent holes should be clean in order to escaping of the gases generates in the cold phase of the refractory body. Treatment. The treatment towards the refractory is the most important in terms of better lives. But the question is how? Let's imagine the well lining thickness is 7 inches, that is 177 mm. In case you are getting 70 hits, does mean due to thermal spall, slag attack, or metal stream and its impact, improper thermal discipline, improper refractory selection, improper properties, etc. We need to understand the root causes. Speaking a continuous auditing after seeing the erosion profile can improve the life statistics up to certain extent. In case the shop is having LRF, then slag making will have an important role. In case of dolomite ladle, magnesia carbon ladle, AMC, the slag compatibility is the most important treatment on the refractory. The refractory erosion is indispensable, but if the slag becomes creamy and compatible, then the erosion will be minimum. Any refractory using the ladle based on the experience and knowledge of the shop manager, it must be understood properly, the specifications, properties, etc. Then right from the storage of the refractories with the shapes, accessories, the user must be knowing the actual behaviors of the shapes and the accessories, whether those are powder or monolithic. It is always recommended that please talk to your supplier who understands better refractory than you. Keeping the shapes and the accessories in proper place, like dry and clean, should not be contaminated with water or any other industrial stuff. And above all, continuous monitoring and improvement plans are the mantra to optimize the lives followed by reduction of the refractory consumption or cost per ton. Say, as an example, the transfer ladle is performing 100 hits, then it is the duty of the shop manager to evaluate the condition, what are the root causes in the deterioration of the refractory lives. Discuss with your refractory supplier whether any specific properties can be to attain a good life so that the refractory cost per ton can be justified. The relationship of slag with stainless steel ladle refractories is critical for refractory wear, steel quality, and ladle life. The choice between dolomite, magnesia carbon, or AMC depends largely on the slag chemistry, basicity, FeO content, alumina pickup, etc., and operating conditions. Let me break it down. Dolomite refractories composition CaO MgO based. Interaction with slag. Good resistance to basic slag. High lime silica ratio. Slag with high FeO or MnO can react with dolomite calcium oxide dissolution leading to excessive wear. Risk of hydration. Calcium oxide pickup, expansion if not properly maintained. Used in SS ladles traditionally used in LD or BOF converters and some ladles for basicity more than 2.5. Less common in SS ladles because low FeO slags are required in stainless steel making, dolomite not always stable. Magnesia carbon refractories. Composition. Magnesia plus carbon. Graphite. Interaction with slag. Very good resistance to basic slag. CONGOH. Carbon provides non-wettability, reduces slag penetration. But oxidizing slags, FeO, Cr2O3 rich, attack carbon, decarburization and erosion. Slag with high Cr2O3 is particularly aggressive on magnesia carbon. Use in SS ladles. Widely used in slag line, most corrosive zone. Needs slag conditioning. Calcium addition to reduce Cr2O3 attack. ANC, composition alumina plus magnesia plus carbon. Interaction with slag. When exposed to slag, in situ spinel, magnesia aluminate forms excellent slag resistance, better thermal shock resistance than pure magnesia carbon, performs well against Cr2O3 FeO slags, common in SS refining, used in SS ladles, increasingly preferred in slag line and impact zones, provides balance between corrosion resistance and thermal stability. Refractory slag compatibility, strengths, weakness. Dolomite, high basicity, low FeO slags, cheap. Basic slag tolerance. Hydration, poor against oxidizing slag. Magnesia carbon basic slag, high corrosion resistance, non-wettability, poor in oxidizing Cr2O3 slag. AMC, Cr2O3 FeO slags, spinel formation, high thermal shock resistance, costlier, more complex bonding. Heat map chart showing the relative performance of dolomite, magnesia carbon, and AMC under different slag conditions in stainless steel ladles. This is self-explanatory. Thank you. Thank you very much for your time and patience. If you have any question, kindly ask in comment section.